Welcome back to this section on system templates and design. In the last section, we mostly discussed waterless pit-based systems, whereas in this section, we'll focus on systems that are mostly water-based, but still contained at the household or decentralized level. This system is called the pour flush pit system without sludge production. The name is a bit long, but it also describes very clearly what happens in the system. First, it is a system based on a pour flush toilet. Unlike previous systems, there is not a choice when it comes to the user interface. This is because the pour flush toilet is water-based, but it doesn't require too much water. Too much water would flood the twin pits. You can see here that there is only one technology option for the collection and storage. To prevent too much water in the pits, the gray water is diverted, although small quantities could be added. Because only one pit is used at a time, the black water in the pit degrades over time into a thick, relatively stable humus-like material. Unlike sludge, which accumulates in single pits, the material from the twin pits cannot be pumped and must therefore be removed by hand, probably with a shovel. Again, there is only one option shown here for the conveyance technology. The material underwent treatment in the pit, so there is no need for further treatment and therefore no technology choice for the treatment option. The material can be used or disposed of depending on local needs. The biogas system is designed with the goal of producing biogas for use in cooking or lighting. This, like the previous system, would be chosen if there was a specific need for the use of the end products, but care must be taken to ensure that the right technologies are selected and organized before. In this template, we can see several choices for the user interface. Either a pour flush toilet can be used for all of the excreta and flush water, or if there is a desire for urine so that it could be used as a liquid fertilizer, then a urine diverting toilet or urinal could be installed. If urine is separated, it must be stored and transported separately. Of course, it could also be directed towards a soak pit, although there is really no reason to do this, and this option is indicated by the thin line leading from the urine to the soak pit. The black or brown water that is generated should be mixed with some sort of organic material in the biogas reactor. Biogas can be produced without the addition of organics, but if they are available, they should be added. The reactor will produce a fairly constant supply of gas, which it must not be allowed to build up or the pressure could become too high and the tank could crack or explode. Important to note also is the fact that sludge is formed within the reactor. Depending on the design of the reactor, the sludge will either be pushed out as the gas pressure builds, or it must be emptied periodically so that the reactor continues to function and so that there is still enough space for the gas to accumulate. Notice again that gray water is treated separately in a parallel treatment train at the top. This is to prevent the mixture in the biogas reactor from becoming too diluted. If a significant quantity of organics or animal waste is added to the reactor, some gray water could be useful. The last system template from this section of water-based, mostly decentralized systems is called the black water treatment system with infiltration. As the name implies, a key feature here is the infiltration that happens. A water-based user interface generates black water, which is collected in an on-site storage technology, like the septic tank shown here, that produces both effluent and sludge. Sludge, as we have seen, requires a number of sequential and sometimes parallel technologies to transport, treat, and use it. The effluent, though, in this case, will simply be infiltrated into the soil using a soak pit or a leach field, both of which require appropriate groundwater and soil conditions, not to mention sufficient space. This system would not be appropriate for a very dense urban area like this one, but would be suitable for a rural or peri-urban application where the distance between houses would not make it possible to connect them with any kind of sewer, but where sufficient quantities of water would be available to ensure that the septic tank or ABR would function properly. In summary, then, water-based systems can be contained at the household level and do not all require water-based transport. Infiltration is the key mechanism that removes the need for off-site transport. For this reason, however, gray water must be carefully managed so that it does not overload the technologies. And end use of some products is still possible with the use of water-based technologies, but as before, requires careful planning. In the next module, I will present the final section on system templates.